Time travel, as a theoretical construct, intertwines with two fundamental phenomena: paradoxes, temporal inconsistencies, and horizons, boundaries of causality. This theory proposes a unified framework where paradoxes are resolved through the existence of dynamic horizons that regulate time travel's effects on spacetime. The three core principles: the paradox principle, self-correcting time. Definition: any attempt to alter the past creates a self-correcting divergence rather than a direct paradox. Mechanism: Type 1 event horizon paradox. If a time traveler alters a past event, the universe bifurcates along a causal horizon, creating a parallel timeline. Type 2 observer paradox. The traveler's presence itself is part of the original timeline, meaning their actions were always meant to happen, a la the Novikov self-consistency principle. The horizon principle, boundaries of causality. Definition: time travel is constrained by temporal horizons, limits beyond which causality cannot be violated. Past horizon: the furthest one can travel back before encountering a singularity of uncertainty where history becomes non-computable. Future horizon: the furthest one can travel forward before entering a probabilistic foam where divergent futures branch infinitely. Implications: travelers cannot cross a horizon without becoming entangled in its quantum state, effectively merging with the timeline. The temporal relativity principle, observer-dependent time flow. Definition: time travel's effects are relative to the observer's position in spacetime. Local time: a traveler experiences time linearly, but their actions may appear instantaneous or delayed to outside observers. Non-local effects: changes in the past propagate at temporal light speed, meaning effects are not immediate but ripple forward predictably, resolving paradoxes through horizons. The grandfather paradox. Classic problem: killing one's ancestor should erase the traveler. Horizon solution: the act of killing creates a new causal branch at the horizon, leaving the original timeline intact. The traveler is now part of the new branch, where their existence is either erased or preserved via quantum immortality. The Bootstrap paradox, self-creating information. Classic problem: an object or idea with no origin, for example, a time loop. Horizon solution: the object exists in a metastable state outside linear time, anchored by the horizon's boundary. Its origin is not a point but a temporal field, an emergent property of the loop itself. The predestination paradox. Classic problem: events are inevitable because they've already happened. Horizon solution: the past and future are entangled. The traveler's actions were always part of a higher dimensional event that appears fixed from within the timeline. Practical implications for time travel: a temporal navigation. Travelers must account for horizon drift, the gradual shifting of causal boundaries due to their own presence. Temporal anchors: fixed points in history that resist alteration, for example, major historical events. The chronoentropic limit: each jump increases temporal entropy, risking fracture, a state where the traveler's timeline dissolves into chaos. Safe travel rule: the 1% law: no more than a 1% change to known history per jump to avoid cascade collapse. Messages sent through time are subject to signal decay. The further they travel, the more they degrade into noise. Quantum echoes: residual imprints of time travelers in the past, detectable as chrono ghosts, temporal after images. Conclusion: the closed loop of time travel is not a disruption but a feature of space-time, where paradoxes are resolved by horizons acting as buffers. The universe enforces consistency not by preventing change, but by integrating it into a multidimensional tapestry of causality. Final axiom: every journey through time is both the first and the last, because in the realm of horizons, all paths are loops waiting to close.